So today we are continuing the yesterday's class, that is power electronic devices introduction. So the now we are going to see about the different classifications of the power electronic devices. First one, the uncontrolled device, a diode. That is, uncontrollable device means it has only two terminals, and the diode is used for especially for the rectification, that is for converting the AC to DC. So the what is the input voltage? Maximum magnitude means that will be get us the same maximum voltage in the output. So we cannot vary the output voltage. So the input voltage maximum value and the output voltage maximum value are same. So that we cannot control the output voltage. So by means of diode, we can only convert or rectify the voltage, but we cannot control the voltage or vary the voltage, so that we can call it as uncontrolled device. The next one, half controlled device are thyristors. So thyristor is the family name, and SCR track are its devices. Half controllable device means so it can be turned on by means of some control signal, and it cannot be turned off by that control signal. So for the thyristor or SCR, we are having the gate current as the turn on or control signal. So by giving the gate pulse, the SCR will get turned on, and after that the gate will loses its control. And if you are removing that gate current means so it will not be turned off. So for turning off the device, we have to reduce or we have to turn off the power circuit. So that is called half control. The on turn on process will be controlled by the control signal, and the turn off process will not be controlled. So that is called half controlled device. The next one, fully controlled device. So fully controlled device means the turn on process and the turn off process are controlled by its control signals. So here MOSFET, power MOSFET, IGBT, GTO, IGCT are the fully controlled devices. If you are giving the gate signal means so it will be turned off, turned on, and if you are removing the gate signal means so it will be turned off. So for to turn on that device, we have to give the gate signal as long as the device in on condition. So the other classifications are current control devices and voltage control devices. So current control device means the control signal is a current. So by means of varying that current, we can vary the output parameters, voltage or current. So the example for current control devices are SCR and BJT. So in SCR, we are varying the gate current to vary the conduction, and in the BJT, we are varying the base current and we can vary the conduction. The next one, voltage control devices or field control devices mean MOSFET and IGBT. In MOSFET, we can vary the gate voltage or gate source voltage. By that, we can vary the conduction. And in also IGBT, we are varying the gate emitter voltage. So by varying that voltage, we can vary the conduction. The next one, power on devices based on the pulse triggered or level triggered. Pulse triggered devices means so a single pulse will trigger or turn on that device. So the example for pulse triggered device is SCRs. After the turn on of process of the device, the pulse cannot be applied, it can be removed. So that is called pulse trigger devices. Then level sensitive or level trigger devices. So it is a constant signal we have to apply as long as the device is in turn on condition. So that it is called level triggered devices. So the MOSFET, BJT and the fully controlled devices are come under the classifications of the level triggered devices. So MOSFET, IGBT, GTO or all the devices is come under the level triggered or level sensitive devices. The next one, unipolar, bipolar and composite devices. Unipolar devices means it is the majority carrier device. Bipolar devices, it means it is a minority carrier device. Unipolar devices means the MOSFET in which the channel, if it is an N channel MOSFET means the conduction is due to the channel formed in that is the N channel. So due to the majority carriers. Bipolar devices means so that will be the conduction due to both the polarity or both the holes and electrons. So BJT is the example for the bipolar devices. Composite devices means it is a combination of both the devices. The next one, the major topics for each device means we have to study about the appearance, structure, there is a construction and symbol, and the operation. The next one, characteristics means it will have two characteristics, static characteristics and it is switching characteristics. So static characteristics means after turning on, After reaching the steady state, we'll have some characteristics of the devices. So that is called static characteristics. Then switching characteristics means it is the transient characteristics. During turn on and turn off process, we will have the switching characteristics. The next one, specifications. What are the maximum voltage, maximum current, and maximum power handling, and what is the temperature to be maintained for the operation of the device, and what is the gate current, and what is the base current of the device. So that are all the specifications. The next one, special issues. So what type of devices can be used for what type of applications? That is major low power applications, medium power applications, and major power applications. And devices of the same family. So the thyristor is a family name, and the SCR, triac, diac are the that family devices belong to that family. So this is a power-electronic converter basic diagram. Already we have shown that it consists of a source and a load. In between we are having this power electronic converters. So the power electronic converters is controlled by a controlled circuit. So the power electronic circuit has it may be any type of converter which converts any type of supply to another type of supply, or it can control the so one type of supply. So the converter consists of some switches, main element, and some energy storage elements, capacitance or inductance, and some energy dissipative element, that is resistance. So these are the basic conversions. So by means of this arrow, we can see that first one we can convert the AC to DC, and again, if it is supply is DC, it will convert the DC to AC, and it may be a cross combination. That is, if it is an AC, we can control or vary that AC, and if it is a DC, we can control or vary that DC. So these are the possible combinations of the conversion. Either we can convert AC to DC, or DC to AC, or AC to AC, AC to fixed AC to variable AC, and fixed DC to variable DC. So these are the names of the converters. So if the supply is AC, if it is converting it to DC, that is called rectifier. And if the supply is DC, fixed DC, we are converting it to variable DC, means it is called chopper. And if it is a DC and it is converting into AC, means that is called inverters. That is DC to AC. And if it is a fixed AC to variable AC, means that is called voltage regulator or AC voltage controllers. So these are the main classifications of the converters. Rectifier, that is AC to DC, chopper, fixed DC to variable DC, and inverter, DC to AC, and voltage regulator, fixed AC to variable AC. So these are the names of that switches. Names of the converters, that is AC to DC converter, that is control rectifiers. So we are calling here it as control rectifiers. So that means we are controlling the voltage, or we are varying the voltage by means of the controlled devices, any one of the control devices, that is except the diode and diac. All the devices are the controlled devices, that is SCR, BJT, MOSFET, IGBT are all the controlled devices. So that is called control rectifiers, so that we are controlling the or converting or controlling the or varying the output voltage. The next one, DC chopper, that is a fixed DC to variable DC converter. AC voltage regulator, that is fixed AC to variable AC converter. The next, DC to AC, that is called inverter. The next one, static switches. So this is the explanation for that. Diode rectifiers is a circuit which converts AC voltage into fixed DC voltage. The input voltage to rectifier could be either single phase or three phase. Here we cannot vary the output voltage. So fixed AC to fixed DC. The next one, AC to DC converters. It can convert AC voltage into DC voltage. The DC output voltage can be controlled by varying the firing angle or the switching angle of the thyristors. So the input can be a single phase or three phase. So here fixed AC to variable DC by means of varying the firing angles. And AC to AC converters. So this can convert from a fixed AC to variable AC output voltage. So it can be controlled by varying firing angle of triac, or it can be a bidirectional connection of SCRs. So this is also called as AC voltage regulators. The next one, DC to DC converters, that is choppers. These converters can convert a fixed DC input to variable DC output voltage, and the DC voltage is controlled by varying the duty cycle of converters. It's a spelling mistake. That is a duty cycle of converters. And it's a static switch because the power devices can be operated as static switches or contactors. The supply to these switches could be either AC or DC, and the switches are called as AC static switches or DC static switches. So these are the some block diagram representation of the converters. So first one, we are having the DC to AC converters. So first one, we are giving the DC, fixed DC, and we are getting the output voltages, variable voltage, variable frequency, AC signal, that is, it is a inverter circuit. Then next one, DC to DC converter. So here we are having the DC input signal and we are getting the variable DC output signal. So it is a chopper. And third one, we are having the AC to DC converter, that is a fixed AC to variable DC. So that is called rectifiers or converters, that is controlled rectifiers. And the last one is fixed AC to variable AC converter, that is a voltage controller or voltage regulators. We can call it as voltage regulators or voltage controllers. Thank you.